Okay, this is lesson 4 in solutions, and today we're going to look at the difference between a dilute and concentrated solution. And we're also going to revisit Table F, which we were working with in our last lesson. And we're going to look at chemical reactions and decide whether or not a precipitate forms. Let's recall that solubility is a measure of how much solute will dissolve in a certain amount of solvent at a given temperature. And we usually use table G when we're talking about that. So soluble means that it will dissolve. Another word for that is also known as miscible. If something is miscible, it means it will dissolve in something else. The more soluble something is, then the more concentrated it can be in solution. If you see this abbreviation like this, that's an abbreviation for solution. Just how also in the past I've told you that RxN is also an abbreviation for reaction. If something is insoluble, then it's safe to assume that it will not dissolve. And this is also known as immiscible. For example, oil and water. And concentration refers to the ratio of the amount of solute per the amount of solvent. So this is basically, when we talk about this, we're talking about the ratio of solute to solvent. Now you've heard me use these two terms this week, dilute and concentrated, in class. A dilute solution is one that has a relatively small amount of solute dissolved in a relatively large amount of solvent. So sometimes we refer to this as a weak solution. So going back to our iced tea analogy, if the directions say put 2 tablespoons in 16 ounces of water, and you put 1 tablespoon, you would have a very dilute solution because you have a small amount of solute dissolved in a relatively large amount of water. So what we're saying is that this means to weaken the concentration of a solution. So here you can see the word solute is very small compared to the word solvent, which is very large. And concentrated is actually the opposite of that. A solution that has a relatively large amount of solute dissolved in a relatively small amount of solvent. And this is called a strong solution. So going back to our iced tea analogy, instead of putting in the 2 tablespoons per 16 ounces of water, you put in 3 or 4. So here you can see the word solute is very large compared to the word solvent, which is very small. And the Regents will ask you questions. Which one of the following solutions is most dilute? So you're looking at which one has the smallest amount of solute per solvent, or it could say which one of the following is the most concentrated, so you're looking for the one that has the greatest amount of solute per solvent. Most versus least concentrated. So now we're going to use Table F. So concentration is directly related to the amount of solute per solvent. And as I said, most concentrated equals aqueous, also aqueous compounds, and least concentrated equals actually I'm going to change this. You can put aqueous, leave aqueous there, but I'm going to also put the word soluble. We're going to add the word soluble because soluble means that it's aqueous, and this is going to be insoluble, least concentrated, and in parentheses I'm going to put PPT. And a PPT is another one of our abbreviations. Remember that it means precipitate. And precipitate is something that forms when two aqueous solutions are mixed together and you form a solid. You get this chunking or sludge on the bottom of your test tube. So if a compound doesn't dissolve, meaning it forms a precipitate, then it can't add to the concentration of the solution. So when we say concentration is directly related to the amount of solute per solvent, it's the amount of solute dissolved, which is important, in the solvent. So let's take a look at some examples where Table F, you would have to use this. Silver nitrate and sodium chromate solutions are mixed together. So this means that these two are both aqueous. They've been mixed with water. Will a precipitate form? And if so, what is the name of the precipitate? So two things come into play here. You have to be able to write a reaction, and you also have to use Table F to determine whether a precipitate forms. So the first thing you're going to do is write the chemical or word equation if you're not given it. So silver nitrate, we know we would write down silver, and that's a +1 charge, and nitrate is a polyatomic with a -1 charge, so when we drop and cross we get AgNO3. Then sodium chromate, sodium is Na with a +1 charge. Chromate comes from our polyatomic chart, -2 charge, so when we drop and cross, that 2 came down here. Now remember that in a double replacement reaction they switch partners. So positive is going to hook up with a negative. So you've got Ag hooking up with, so this is Ag plus CrO4, which is -2, so you're going to get Ag2CrO4. And then your other product, you've got your plus hooking up with your minus, you've got Na plus and NO3 minus. And that's how we got to this, +1 -1, we're good. And then to balance the equation, you see that you've got 2 Ags here, so you had to put 2 here. And that gave you 2 NO3s, so you had to put 2 here. And then the 2 Nas balanced with the 2 Nas. So once you have your balanced equation, now you're looking at your two products. You're looking at NaNO3, and if you look at Table F, which you should have out, nitrates are always soluble, no exceptions. So this is going to be aqueous. But if you look at your chromates, chromates fall on the insoluble side of Table F, and Ag is not an exception. So this is our precipitate, and we would put an S after it, meaning it forms a solid. Let's just do a couple of reactions for practice. Will a precipitate form when lithium nitrate is mixed with potassium phosphate? So here they gave us the balanced equation. We're looking at the two products. Well, we just said nitrates are soluble, no exceptions. So that's going to be aqueous. and phosphates are soluble, and lithium's a group 1 element. So this is also aqueous. Now here they want you to actually write the reaction. So silver nitrate, we already did that. That's Ag, NO3, because Ag is +1, NO3 is -1. Potassium chloride, potassium is K, chloride is Cl. This has got a +1 charge and a -1 charge, so we don't have to drop and cross here. So this is your +1 and this is your -1, so AgCl, and potassium hooks up with the nitrate, KNO3. And all of these are +1, -1, so we're already balanced. When I look at nitrates in Table F, they are soluble with no exceptions, so this is going to be aqueous. However, if I look where the chlorines are, they're under the halides, they are aqueous unless combined with silver, lead, or mercury. So here's my exception. It combined with silver, it's going to form a precipitate or a solid. So we're going to circle this one. Okay, copper 2 sulfate. This is why being able to write compounds was so important. So copper is Cu. They're telling us we're using the +2 charge on copper. And sulfate is a polyatomic, SO4, and this is -2. So I'm just showing you that these combine at a 1-to-1 ratio. Sodium is Na, and that's +1. And hydroxide's a polyatomic with a -1 charge, so they also combine at a 1-to-1 ratio. On the other side, my positive is going to hook up with my negative, so I'm going to form sodium sulfate, so Na +1, and my sulfate was -2, which means that when I drop and cross, this has to be Na2SO4. And copper was +2, hydroxide was -1, so when I drop and cross, this 2 has to come down here, and now we have our two products. Let's balance the equation. We need 2 OHs, so I'm going to put a 2 here. I have 2 NAs, good. 1 SO4, 1 SO4, and 1 Cu. So that's all I had to do was put the 2 there. Now let's look at my two products. Sulfates are soluble when they combine with a group 1 element. So this is going to be aqueous. Okay? And hydroxide is going to be insoluble unless we meet the exception, and copper is not one of the exceptions, so this is going to be my solid. So that's my precipitate. Okay, I'm just going to finish up with a quick video clip that shows you the actual formation of a precipitate so you know what to look for when we do a lab on this.
The first precipitate will be produced from aqueous silver nitrate and aqueous sodium chloride. Aqueous sodium chloride is added to the silver nitrate solution. We observe a white precipitate of silver chloride. This heavy precipitate thickens and falls to the bottom of the test tube as more aqueous sodium chloride is added to the silver nitrate solution. This is a white precipitate of silver chloride. Again, we take aqueous silver nitrate. This time we are going to add aqueous sodium iodide. When the sodium iodide is added to the silver nitrate, we get a pale yellow precipitate of silver iodide. Note that this precipitate is not the same color as white silver chloride. It is very pale yellow or cream colored. The cream silver iodide falls to the bottom of the tube and begins to form thick lumps.
Okay, that's it. See you in class on Monday.